That's a hard one, but I'll try. So we know, of course, classical computers which calculate with 0 and 1s. And with a quantum computer, we can calculate with qubits. And what those entangled qubits, that's what we call them then, when they are entangled. And if you affect one qubit, you can affect the other qubit with your algorithm. And that opens up a whole new space for developing algorithms. And that's what you can't do with a classical computer. So those entangled qubits are the key for creating way more powerful algorithms. So I wanted to actually show you with this apple how you can visualize a 2-qubit system on a on an apple or on a blocksphere, they call it, or on a planet. And basically, if you have a classical computer, you just have the top North Pole and the South Pole in a classical computer to calculate with. But on a quantum computer, you can take every point on this apple to use quantum computers to calculate with those kind of points on the apple. So this is this extended state space you have with a quantum computer you can develop more powerful algorithms with.
Well, of course, I have to say the most challenging trend for me is drug development and discovery. That's the reason why we chose to operate in this field. Okay, I believe that there are reasons why they are so trendy and so interesting. The first reason is that we do have already a clear understanding of how quantum simulation of molecules could be beneficial in the industry. So there is a concrete example, and is more of a near-term example rather than a longer 20 or 30 years to go. And the second important reason is that, well, the drug development and discovery industry is experiencing a major roadblock. And this roadblock can be seen by the fact that the number of new molecular entities that are discovered are more or less constant over the years, while the number of investments is growing really and doubling every year. So clearly there is something which is not happening. And of course, finally, the other super important point is that this potentially can be so much useful for humanity. So there is the aspect that we really want to have an impact for something that is important to everyone.
So I think one of the key challenges is really whether we can build these huge quantum machines. So it's a technological challenge that we don't know yet how big a quantum system can we actually build, and what are the technology advancements that needs to go into that in order to grow these quantum systems bigger and bigger. So that of course requires investments, and it requires high-risk investments in the technology area, and long-term and high-risk investments and patience to grow this technology further. You can say, what if it fails? I think we are pushing the technology boundaries beyond current limits, and I think that's also really a spin-off of the technology development that quantum computing is doing. I mean, we're really pushing boundaries, and there will be spillover to many other areas that can make use of all this technology. Just like when we were putting a man on the moon, all the technology spin-off that came out of that, or when CERN was built to the particle accelerator. I mean, the technology has massive spillover in society, and I think quantum computing technology would be an area like that as well.
I think that quantum computing, quantum technologies in general, requires a new frame set in terms of how you approach a problem, and in that sense, it's very similar to the rapid evolution of techniques and technology we have seen in machine learning and artificial intelligence over the past 5 to 10 years, where you start to need to be able to transfer into this mindset of using a different way of approaching a problem. And instead of now thinking about the data and big data in terms of what kind of machine learning algorithms do I need to use, in the future you will need to think about how can I approach my problem in a quantum mechanical way.
Quantum computing is a very young area of field of interest. So the playing field is wide, and there are comparably very few active players on the playing field. My suggestion is to embrace the technology, get the knowledge necessary to understand exactly what this is about, and find a way of bringing the field forward. Find something that brings something new to the field, and I'm certain that the effect of that will be much interest. We're seeing a large influx of money right now. Venture capitalists are increasingly being interested in this field as they see the possibilities. And again, get a good idea, understand the field well, cooperate with others, and bring something new. That will be my first suggestion.
I don't think it's going to be a general purpose computer. Somewhere I read, I don't know, don't quote me for this number, but somewhere I read out of the 9 billion people in the world, only close to 1 billion people have ever been getting on an airplane. All right, so I don't think at the end of the day everybody is going to get on this. There's no use for everybody. We have general purpose computers that is fulfilling and serving the society at large, but I hope that all who need it can have access to it.